Hey everyone, happy Tuesday, happy Tuesday. Of course, I'm not there again. I'm doing my best to get back as soon as possible. So just a couple things, guys. For today's lesson, we are starting a new unit, and it is kind of one of the what I would consider the most important, the most valuable unit of semester two when it comes to geometry. It's on trigonometry. So the other thing that I want to kind of mention is if you did get that notebook, I would appreciate it if you guys took notes. In that notebook, we are going to be referencing, and those notes are going to come in handy. You are going to need those you are going to need those examples so that you can reference them. So I am going to ask if you do have a notebook. Again, please make sure you jot down your notes inside of that notebook, starting with this warm up and then the notes section. Of course, when we get to the class activities, just again, please make sure the class activities are done on a completely different paper, not part of your notes, because those will be turned in. Eventually, we'll check your guys' notes, but not right now, of course. So again, make sure class activities on a completely different, separate piece of paper because you will be turning it in. All right, so if you do not have your notebook as well, please try to get one next week. I will not be giving you guys go formatives or anywhere really to jot down your notes, so you want to make sure you have a notebook by next week, please. So if you do not have a notebook, feel free to open up the go formative and follow along through there, right? Open up those slides and then make sure you're jotting down your notes. Um, so at this point, guys, take a minute, see if you guys can find the missing side. So this is where you got to use Pythagorean theorem, what we talked about yesterday, a squared plus b squared equals c squared. So take a minute, try it on your own. When you're ready to see the solution, go ahead and hit play. All right, so here we have a right triangle, guys, and we are trying to find a missing side. They give us two of them. So we are going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. All right, so at this point, why is that thing iron? I hope that doesn't show up for the entire video. Um, Sorry, guys. Uh, Man, I'm all over the place. All right, so we are trying to find a missing side. We have a squared plus b squared equals c squared. If you remember from yesterday, I told you guys it is finding the letter c because it represents your hypotenuse. That letter c, the hypotenuse, is super unique, so it has to go in the correct spot. How do you find your hypotenuse? Find that perfect corner, that 90-degree corner, and go walk yourself directly across, hit that wall. This right here is what we consider your hypotenuse. This is your hypotenuse where it says 15 centimeters. And that is always going to be our letter C. We want that one to be the letter C. These other two sides, which we call legs, it really does not matter which one's A or which one's B. Obviously, they gave us this one as B, so I'll be marking this one over here as A. Okay, now let's go through and plug it in. Make sure you guys plug it in correctly. So A squared, which in this case was 12 centimeters, 12 to the second power. Whoa, 12 to the second power plus b to the second power. Well, that's the one I don't know. What is going on? This is frustrating. All right, b to the second power is equal to c to the second power. And we know that c is our hypotenuse here, which is 15. 15 to the second power. All right, give me a minute. I'm going to pause this video before I break my computer. Trying to figure out what is going on. This is frustrating. Sorry, I don't know if it shows up on your. All right, we'll work with it. Whatever. All right, so at this point, guys, we just basically have to go through and multiply a couple of things, right? It turns into just an algebra 1 problem. So what is 12 to the second power? 12 times 12, that is not 12 times 2, that's 12 times 12, which is 144 plus b squared. I can't do anything with that yet. And then 15 squared, that means 15 times 15. That gives me 225. All right, let's keep it going. I'm trying to solve for that b. So what I'm going to do next is get rid of the 144 by subtracting that from both sides. 144's cancel. We're left with b to the second power is equal to 225 minus 144. That gives me 81. Now, don't forget, a lot of students like to think that this is their final answer. They forget that there's a 2 there, b to the second power. How do we get rid of the power of 2? We do the inverse, which is to take the square root, and we do that to both sides. The square root here and the power of 2, those two things cancel each other out. You're left with b is equal to the square root of 81 is simply just 9. So this missing side length over here, guys, this one measures 9, and I'm going to go ahead and include my units. Make sure you guys include those units. It is 9 centimeters. The length of that bottom side there measures 9 centimeters. All right. So moving on, guys. Today, like I said, we are starting a new unit. I would consider this kind of the most important one for semester two, or like the the main topic for semester two, and it's what we call trigonometry, trigonometry. Um, Now for the first couple of days, guys, this week we're not gonna be solving anything. I don't want to get to solving. I don't want to be solving anything. All you're going to be doing is you're going to be setting up problems. All right. You're going to be setting up what we call trigonometric ratios. All right. We're going to be looking at a triangles, identifying a couple sides, and then writing a fraction. All right. That's what we'll be doing. We're not solving anything. We're just setting it up. Eventually, next week, when we get more into it, we'll actually start to find missing sides and missing angles. And that's actually where I should have started. So what the heck is trigonometry? Just real quick, you're going to have a triangle. You're going to have a right triangle. And I will give you things like, maybe I'll give you this angle down here is 32 degrees. And maybe I give you that the hypotenuse here measures 21 centimeters. And using trigonometry, what we can do is we can actually find all the sides, we can find the angles. So I can actually find the distance of this side here, I can find the distance of this side, I can find this missing angle on the inside. I actually know this corner is 90 degrees. But again, that's what trigonometry helps us do. It helps us find missing sides and missing angles of a right triangle, which is really, really, really neat. So trigonometry, again, this is a, whoops, let me change that. Trigonometry, what is trigonometry? It is a branch of mathematics that studies the relationship involving lengths and angles of a triangle, right? So the lengths and angles of a triangle. Um, so if you take a look at the picture over here on the right, it is these words here, hypotenuse, opposite, and adjacent, those are going to become super important because we will be needing to label certain bits and pieces of our triangle. And then this other little thing here, that's what we call your reference angle. It's pronounced theta. I think this is how you spell it. I'm not an English teacher. That's theta, and it looks like this. It's a little circle, and we use squiggly through. That is what we call theta. And we normally, it's just a variable. Think of it like an x. It's just a variable to represent a angle that we were looking at, or we're referencing, our reference angle. Okay, so moving forward here. Whoops. I forgot to mention one thing. So this reference angle is actually really, really important. I forgot to. So again, that theta is super important. That is going to tell you where's your opposite side, which one's your adjacent. You want to think of this theta as kind of where you're standing, right? So imagine you have this room. It's a triangular room, and imagine I picked you up and I dropped you in this corner over here. Well, you are that little reference angle right there. This is you. That theta right there, that is going to be you. And everything is based off where you're standing or where you're sitting, depending on how you landed there. So let me kind of talk about why do we call it opposite, adjacent, and hypotenuse. So imagine I picked you up and I dropped you in that corner right there. Well, what you want to do is you want to start labeling what sides are what. If you walk directly across from where you landed, that reference angle, if you walk directly across that other side over here, this is what we call your opposite. And that's going to become important, right? Labeling what side is your opposite. So again, wherever you're standing, if you always walk directly across and you hit the wall on the other side, that one will be our opposite side. That's the one I always like to identify first personally. Okay, the next one that I like to identify is the hypotenuse. Why the hypotenuse? It's pretty quick. How do you find your hypotenuse? You find that perfect corner, that 90-degree corner, and you walk across until you hit the other wall. That is going to be your hypotenuse. That is the longest, like we said earlier, that is the longest side. The one that I like to leave for the end is what we call your adjacent. Why is it called adjacent? Adjacent means next to. It's next to your reference angle. Other than the hypotenuse, it's the side that is touching that reference angle. Now, all of these can change. Opposite and adjacent can change depending on where you landed. So imagine that we did not land there. Imagine I placed you on this other corner. Well, a couple things are going to switch because this no longer will be your opposite side, right? Remember, opposite is if you walk directly across and you hit that wall. This would now become your opposite side. Okay, so that's why that reference angle is super important. That's why we're not really going to be solving anything. We're just going to be setting up the problems. If we can't set up the problems, we're going to have a really, really tough time. So the importance of the reference angle. So what I want you guys to do is pause the video here, and see if you can label what's your opposite, what's your hypotenuse, what's your adjacent. All right, when you're ready to see the solutions, go ahead and hit that play button one more time. Okay, so take a look at the first triangle. Here is my reference angle. This is where I landed. This is where I was placed in the picture. So what, like I said, what I want to do first is identify the opposite side. So if I walk directly across to the opposite side, I'm just going to label that OPP for opposite. I just like to abbreviate it. That is our opposite side. The one I like to identify next is the hypotenuse. I always like to find that perfect corner. Walk directly across that one. Whoa, what happened there? No, don't walk that way. Walk directly across from that. That one is going to be my hypotenuse. That's my hype for short. And then, of course, the last one, well, that's just the remaining one. This is why I like to leave the adjacent for the end. This side here is going to be your adjacent side. That is our adjacent. That is our adjacent. Now, take a look. These triangles can be flipped upside down, right side up, all rotated, whatever you want to call it. But again, that reference angle tells us where's our opposite, and again, where exactly things are going. So please be careful. Please be careful. So one more time, let's try it with the second triangle. Here's my reference angle. If I walk directly across until I hit the other wall, that is what's going to be called my opposite. All right, the next one, like I said, that I like to identify is my hypotenuse. Find that perfect 90-degree corner. Walk across that one next. That is your hype, right? Take a look. The hypotenuse is now kind of the bottom of that triangle, which looks a little weird, but that's the way that it works. That's the way that it kind of ended up, given our reference angle in our situation. The last one is this side over here, which is just going to be our adjacent, right? The adjacent is the one that touches the reference angle other than the hypotenuse. All right, we got one more. And again, this labeling, it's super important, guys. Do not take this for granted. Here's my reference angle. Let me walk directly across till I hit the opposite wall. That's my opposite. And yes, please label it. Label it opposite, or OPP for short. Label your hypotenuse, your hypotenuse or hype. Let me find that perfect 90-degree corner. If I walk across, hypotenuse. Please label, please label, please label. Do not just try to rely on your memory. Trust me, when I start adding numbers and a couple of other things, you can get jumbled up pretty quickly. The last one, guys, is over here. It's kind of cut off on my screen, but this side over here, this side would be my adjacent. All right, so hopefully we understand the importance of the reference angle and how to label the opposite, the adjacent, in your hypotenuse. Okay, um, so we have something called Sohcahtoa. All right, Sohcahtoa. What is Sohcahtoa? Sohcahtoa is a mnemonic device for remembering the definitions of a trigonometric function. It's just a way to memorize the following functions, right? Sohcahtoa, and I'll explain how this works here in a minute. So we have these three functions: sine, cosine, and tangent. And again, one more time, that is not sin. I'll show you guys that it actually says sine. This one says cosine, but we just write cos. And then the last one is tangent, but it just says tan for short. And of course, you see these little reference angles, I'll explain a little bit more here in a minute. But what do they refer to, these trigonometric functions? What is the relationship for sine? Sine is opposite. That O stands for opposite over H, which is your hypotenuse. All right, great. What is the relationship for cosine? Well, cosine here is equal to your A, which is your adjacent, over your H, which is your hypotenuse. That's going to be the ratio, the fraction we're going to be setting up here. And then, of course, the last one, tan or tangent, right? Tangent, I should say tangent. Tangent of theta is O over H. Well, that's opposite over A, which is adjacent. This is a lot to remember. So how can I memorize that? We have this mnemonic device called Sohcahtoa. And the way that I actually prefer to write it is in the following way. So Sohcahtoa, I like to write it this way. So S, the giant S, and then I'll write O H, and then I'll write ka, the letter C, and then a smaller A over H, and then T Toa, O over A. The reason that I write it that way, Sohcahtoa, is because it's going to help me remember these little fractions, little ratios. What's the relationship here, right? If we take a look at it, So the so part, that's O over H, that is opposite over hypotenuse. Um, the cosine part, so the cut part, that is A over H, that is my adjacent over my hypotenuse. The TOA part, the TOA, is O over A, so that is opposite over adjacent. So again, this is just kind of a nice way of memorizing. I am going to ask you guys, write that every single time on top of your assignments, on top of your test. Write that down. Sohcahtoa, 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 Sohcahtoa. Make sure you memorize that. Memorize that. Have it as a reference. I would always write it on the top of any assignment or test. So what is sine? So again, let me kind of get a little bit more into it. So again, it used to just say sin of theta, but we pronounce it sine. That's the actual name. Sine. It's the ratio of the length of the side opposite to the reference angle over the hypotenuse. That's a lot. That's a lot. It's basically saying it's the relationship between your opposite side and your hypotenuse. Sine is opposite over hypotenuse. And again, so the so part, that's the way we memorize it. Of course, I'm going to write it one more time. So, Sohcahtoa. All right, cosine. The next one, the ka part in Sohcahtoa. Right. So let me write that one more time. Sohcahtoa, not Sohcahtoa. Sohcahtoa. Cosine. Right, and we normally use just cos, but it's the ratio of the length of the side adjacent to the reference angle over the hypotenuse. That's a lot to take in. All it's basically saying, it's comparing your adjacent over your hypotenuse. All right, it's going to be comparing that adjacent value over the hypotenuse value. And again, that is the ka part in Sohcahtoa. So you see that A over H, your adjacent over your hypotenuse. All right, and of course we have the last one, tan, for short, but it's really pronounced tangent. This one, same thing. That's a lot to take in, that technical definition there. It's basically a relationship here between the opposite and your adjacent side. So if you write Sohcahtoa, whoa. I prefer to write the other way. Sohcahtoa. That TOA part at the end here, it's O over H, so it's going to be your opposite over your adjacent. All right, so how do we use this? How, like I said, you won't really see the how do we use this to find missing sides or angles, guys, until next week. What we're going to be doing is we're going to be using Sohcahtoa, sine, cosine, and tangent, just to set up the problems. We're going to imagine you had tangent. We're going to be writing things that look like this today. Tangent of theta is equal to, and then just two numbers, something like 5 over 7. We're going to be setting up the problems. Next week, we'll actually go through and work it out to find a missing side or angle. So take a look at example 1, guys. It says, find sine of angle B. Write the ratio as a fraction. So I have to do two things. I'm going to write that ratio as a fraction in reduced form. So we do want to simplify it. And we're also going to write it as a decimal, rounded to the nearest hundredths. I'll get a little bit more into that a little later. So let me, before I forget, so and again, I would write this every single time. Whoa. No, I messed it up. Eraser. Sohcahtoa. There we go. I would write this every single time. So let's begin by labeling. This is what you have to do first. You want to start by labeling your triangle. What's your opposite side? What's your adjacent side? What's your hypotenuse? Now the question is, well, where am I standing in this picture? Right? And that's the big question. Where am I standing? Am I standing over here at angle B? Or am I standing over here at angle A? You're not going to be standing here at that 90 degrees. You'll actually never be standing there at that perfect corner. You'll either be standing at B or at A. And it does make a big difference where you're standing. So where do you think we're going to be standing for this one? They're asking us to find sine of angle B. So I'm actually going to put my reference angle. We're going to place ourselves. We're going to go ahead and sit down, pop a squat here on angle B. So go ahead and put that theta there, put that reference angle. And we're going to start labeling your opposite side, your adjacent side, your hypotenuse. So like I said, once you know where you're standing in the picture, your reference angle, I would immediately walk across till I hit the opposite wall. That 12 there, that is going to represent my opposite side. Next thing I would do is I would find that perfect 90-degree corner. I would walk across that one. That is considered your hypotenuse. That 13 right there is my hypotenuse. It's the longest side. And then, of course, the last one here, the 5 from B to C, that is my adjacent. Right? I always like to save that, like I said, that one for the very, very end. Great, fantastic. We went through the hard part of actually labeling, identifying your hypotenuse, opposite, and adjacent. Okay, so this is what's going to happen. Now, they're asking us to find sine of angle B. If I look back at Sohcahtoa, we're not going to be using the ka part. That's cosine, so we're not looking at that. We're not using the toa part. That's tangent. We're going to be focusing on the so part here. So what I'm going to do is I'm going to rewrite that. Why did I write that? Because it's going to remind me that, hey, sine of my reference angle is going to equal, so that means opposite over hypotenuse. So I'm going to write that out, opposite over hypotenuse. And what we're going to do here is we're basically just going to go ahead and plug in. You're just going to plug in based off of your picture. So here we're going to rewrite this as sine of theta, but instead of theta, we actually know where we're standing. That angle actually has a letter there. So we're going to say sine of angle B. Sine of angle B, because that's where my reference angle is equal to, and then again, take a look at what So in Sohcahtoa is saying. It's saying opposite. So find opposite. Where's opposite? We labeled it over here. That was 12. So we're going to write 12 over, what's my hypotenuse? So that's opposite over hypotenuse. Hypotenuse is 13. So sine B is equal to 12 over 13. So when I say, hey, I need you to write the ratio as a fraction, this is what I'm looking for. And this is actually already simplified. 12 over 13, you can't simplify that, so we're going to leave it as 12 over 13. That's it. That's all we're doing today, is just setting up the problem. So that is the first answer. I'm also looking for the decimal. All I need you to do, guys, is divide 12 by 13. What is 12 divided by 13? Let me get my calculator out. I'm going to rewrite the other answer that I'm looking for. Sine of B, that stays the same. That is equal to, what's 12 divided by 13? That gave me 0.9230769, and it goes on for a while. But we want to round to the nearest hundredth. That's 2 spaces after the decimal. So if I take a look to the right of that 2, that's a 3. So this should actually say sine, well, sine of B is equal to 0.92. All right, so there we have it. Those are the two that I'm looking for. I'm looking for the ratio, the fraction, and I'm also looking for the decimal. Sometimes one is preferred over the other, so you want to be able to go back and forth, back and forth, back and forth. All right, and so there we have it, guys. That's just setting up the problem. What is sine of angle B? Sine of B is 12 over 13, or sine of B is equal to 0.92. All right, moving on. Given the right triangle, what is the value of tangent of A? So again, before I even get started, let me write Sohcahtoa. Write it down, write it down, write it down. If you're taking notes on your notebook, I would write that at the very top of every single page for this unit. So I want to find tangent of A. And again, I want to write it as a fraction, simplified fraction, and I also want to write it as, let me write that as a ratio. In reduced form, and I also want it as a decimal to the nearest hundredths. Like I said, before we get into it, you have to know how to label your triangle. It all comes down to your labeling. So where should I be standing at? Take a look at the question. Tangent of A. I'm gonna pop a squat here at angle A. That is where you should be putting that reference angle. Now let's go through and label the rest of it. If I walk directly, now that you know where you're sitting, if you walk directly across and you hit that opposite wall, that 24 here is my opposite side. Find that 90-degree corner, walk across that one. That side right there, that is your hypotenuse. Hypotenuse should always be the longest side, and it makes sense, it's 25. And that means that this remaining side down here, that is our adjacent from B to A. Great. So now that we have that, let's go back and take a look at what they're asking for. They're asking for tangent of A, not the so part, not the ka part, not Sohcah, but the toa part. So I'm going to rewrite that toa. That refers to tangent of theta is equal to O, which means opposite, over A, which means adjacent. And again, Sohcahtoa, guys, is just a nice way to memorize all these little trig functions. It's just a nice way to memorize it. So now that we know, hey, we're working with tangent of theta is equal to opposite over adjacent, let's plug in what we know. Let's plug in what we know. Tangent of theta, well, I'm going to rewrite that as tangent no longer of theta. I know my reference angle here was at angle A, so we're going to say tangent of A is equal to opposite. What was the opposite side? 24 over what was my adjacent side? That was 7. 24 over 7. So there you have it, guys. That's as crazy as I want you guys to take it. We're not solving, like I said, we're not solving anything. We're just going through and setting up the problems. Now, I don't think that divides nicely, so we're just going to go ahead and leave it like that. It does not simplify. So that is my ratio in reduced form. Now, let's also give the actual decimal. Let me actually divide 24 divided by 7. That gives me 3.428. So tangent of A is equal to 3.428. So we're going to stop there since we have to round to the nearest hundredth. So I take a look at the 2. I take a look to the right of 2. That's an 8, so we do have to round up. Tangent of A is equal to 3.43 if we round correctly. So there you have it. There's the ratio in reduced form as a fraction, and there it is as a decimal. Those are the two things I'll be looking for today. All right, last one here, guys. So before I forget, so and again, I'm not playing about this part here, guys. I highly recommend. I'm not exaggerating. Write it down. Write it down. Write it down. Commit it to memory. Commit it to memory. Sohcahtoa. 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 I need you to have nightmares about it. So this one says, what is the value of cosine? And again, we're going to write the fraction and also the decimal. But again, we got to start. We'll go back. We got to start by labeling your triangle. Label your triangle. And this time they say cosine of theta. They actually already give us where we're standing. Theta's right here at angle R. So let's label what's your opposite, what's your adjacent, what's your hypotenuse. So now that I know that my theta is here at R, let's walk across to the opposite wall. That 5 there, that's going to be my opposite side. Find that 90-degree corner. Walk across that one to the other wall. That's going to be your hypotenuse here. So that 13 is my hypotenuse. That means that the last one here is my adjacent. Like I said, I always like to leave the adjacent to the very, very end. Okay, so let's go through. So which one are we dealing with here? We're not dealing with sine, so not the so part. We are dealing with the ka part, but not the toa part. So the soka, the ka and Sohcahtoa, C, A, and H. Well, that means cosine of my reference angle is equal to A, which stands for adjacent, over H, which is my hypotenuse. And again, that's just to memorize which numbers are we throwing on top of which numbers. If we go through and we plug in what we know, we're going to say cosine. And again, instead of saying theta, I know theta was sitting over here at angle R. So we're going to say cosine of R is equal to, what is my adjacent? Adjacent was 12 over, what's my hypotenuse? My hypotenuse was 13. So there we have it. And again, that does not simplify nicely. So we're going to go ahead and leave it as cosine of R is equal to 12 over 13. Let's say, for example, so here, example, let's say you had a fraction something like 5 over 10. Yes, I would appreciate it if you guys can do me a favor and simplify that by 5. You would end up with 1 over 2. So if that ever is possible, please go ahead and do that. Again, this was just a little side example. Whoa. But 12 over 13 doesn't simplify nicely. All right, so there is the fraction in reduced form. Let's actually divide that to give the decimal. 12 divided by 13 is equal to cosine of R is equal to 0.923. We take a look at the 2, that's the hundredths place. Take a look to the right of it. That's a 3, so we're going to let it rest, right? Cosine of R is equal to 0.92. We don't round up, we leave it as 0.92. Again, there's your ratio in reduced form. There is your decimal. All right, guys. So for your class activity, again, make sure this is done on a separate piece of paper. You will be checking your answers with my sub. They do have the answer key. A couple things that I want to point out, guys. There are two problems. You're using the same triangle for two different problems. Um, so for this first half right here, sine of p, cosine of p, tangent of p, make sure you put your reference angle at angle p, label your opposite, adjacent, hypotenuse, the rest of it. And go through, give me the fraction, and give me the decimal for each one. All right, so you should actually have a couple more of these. Okay. So I do want the fraction and the decimal, just like we've been doing. Once you're done with that, what I'm going to need you to do is you're going to go through and you're going to erase all that labeling that you did. And then for the second round, you're still using that same triangle, but you're going to be doing it for cosine of n. So your reference angle moved from angle P. It's now going to be over here at angle n. So it will affect what's your opposite and what's your adjacent. So please be careful. You have two problems in one. Same thing for this one. I do need the fraction, and I also need the decimal. All right, guys, there you have it. There you have it. So go ahead and get started. Once you're done, check your answers. Everything's perfect. Turn it in. What you don't finish does become homework. So take care, guys. Have a wonderful day. Adios, adios, adios.